Assalamualaikum and good morning. Today I'm going to present our KIX2006 Engineering Economics and Project Management. So this is our video project presentation for our topic Design and Cost Analysis of a Home-Based Water Filtration System Using Natural Materials. So this is our team members. Our team consists of 4 students: Hadif Harry, Iman Nul Zulkarnain, Amirul Hakimi and Ahmad Aziz Azrin. For introduction, the project aims to develop an affordable, eco-friendly and easy-to-build water filter for home use, especially in rural areas. It uses natural materials like gravel, sand and charcoal for an effective and chemical-free filtration. The system will be multi-stage and operate without the need of electricity. A full cost analysis including break-even, payback and return on investment to determine the best solution are also covered in this project. The project also covers planning, budgeting and scheduling. Beyond performance, it emphasizes sustainability by using recycled materials and minimizing plastic waste while encouraging eco-conscious living. Next, we move on to the importances of the project. First, it helps people get clean water at a lower cost, works without electricity so it can be used anywhere, uses natural and eco-friendly materials, minimizing plastic waste and supports environmental care, and last but not least, raises awareness about safe and sustainable living. Now, the objectives of our project are to design a home-based water filtration system using cost-efficient natural materials and to evaluate the practicality, health, safety, and environmental impact of the proposed system. Now, for potential impacts, we view it from 4 different aspects. The first one is organizational, streamline operations by providing a low-maintenance, sustainable water solution for distribution programs. Next is economic, which is reduces costs for households over time versus bottled water or branded filters. Next, social aspect, which promotes community awareness on natural solutions for water treatment. And lastly, is environmental, to minimize plastic waste and carbon footprint. Now, we are moving on to our project plan proposal. The first one is the project overview. The proposed water filtration system will consist of a multi-stage filtration unit using gravel, sand, and charcoal as a filtering mechanism. The design will be modular for ease of maintenance and constructed using affordable and locally sourced materials. Next is the project scope to supply a water filtration system that is eco-friendly for in-house use, especially in rural areas. Equip a house with a multi-stage filtration system that does not require professional installation. Next, improve household health and hygiene by reducing common waterborne diseases. And lastly, use natural, biodegradable, and recyclable materials such as sand, gravel, and charcoal.
For detailed tasks and responsibilities, all of these positions are crucial and necessary for our project. For the project schedule, we will use the Microsoft Project application for doing the Gantt chart. The details of our Gantt chart and the right side is the Gantt chart itself. We use the previous engineering course KIG2016 to help us guide scheduling our project. All of this happened in the span of around 20 weeks. We can view the cost, which is the resource allocation for each phase, and finally, we can view the resource sheet.
For our investment evaluation parts, 4.1 initial cost and cash flow estimation, this is all of the details, and our total project cost, which is initial investment, is 80,136 ringgit. We want to sell our product 60 ringgit per unit, thus our total revenue, 2,000 units, is 120,000 ringgit, and our net annual cash flow is 39,864 ringgit. For our net present value NPV, we choose 5% for MARR, and we gain a positive value of NPV through calculation. Thus, it shows that our investment is financially strong and it will give benefit to the investor. For our internal rate of return, we gain 36.5%, which is higher than MARR. That shows the project is highly attractive and also excellent for our investment performance. For payback period, we undertake short period of time, which is 2.01 years. It shows that our investment is low risk, community technology, and also highly acceptable and attractive to stakeholders. For parts 4.5, which is cost inflation scenario, we assume the variable cost to increase 20% in the future, and we calculate again our NPV, and we gain also positive NPV. Thus, it shows that our financial is very strong in this project.
In this section, we explain how we manage our resources like people, materials, and time throughout the project. Our goal was to build a low-cost, eco-friendly water filter that's simple to use, especially for communities with limited access to clean water. To achieve this, we carefully plan and assign tasks to the right team members. We use natural, low-cost material like sand, gravel, and charcoal, and focus on efficient teamwork and scheduling. This helps us keep the project on time, within budget, and effective in meeting our goals. Our water filtration system is designed to be affordable and easy to maintain, especially for low-income and rural households. It uses a modular design with recyclable materials like sand, gravel, and charcoal, so user can clean or replace part without any special tools. The prototype was optimized to keep costs low, deliver effective filtration, and provide a quick payback period, making it a practical and a sustainable solution. To make sure everything runs smoothly, we follow a clear project planning process. This started with defining the project scope and selecting natural materials. Then, we designed the prototype of the materials and built the first unit. After testing for quality, we moved to full production. Finally, we compiled the result and completed the final report. Each phase was carefully managed to ensure we're staying on track, on time, and within budget. Our project had several constraints that needed to be managed carefully. First and foremost is financial. The total project cost was capped at RM 80,136 with unit cost at RM 40 and 7 cents including all fixed and variable costs. Next is material availability. We use only locally available and safe natural materials. Third one is time. The final project submission is due on 23rd June 2025, requiring precise scheduling. Next is technical. The system must operate without electricity or complex machinery. And finally, it is user accessibility. It must be simple enough for non-technical users to assemble and maintain. This project solves several real-world problems at once. It addresses the economic issue of expensive bottled water, the social problem of unsafe drinking water in rural areas, and the environmental impact of plastic waste. It also helps organizations like NGOs that need affordable water solutions for communities. To manage the project effectively, we use a mix of resources allocation methods. Team roles were assigned based on skill, materials were chosen based on performance and price, and tasks were scheduled to meet deadlines. For example, we use sand, gravel, and charcoal as the main filter materials. Each unit included a 5-liter container and labor cost for assembly. The total cost per unit is about Rm20 ringgit and 87 cents. Fixed costs cover salaries and rent, while variable costs depended on how many units we produce. By planning carefully and assigning resources wisely, we keep the project affordable, efficient, and ready for real-world use. This project offers strong benefits beyond technical results. For organization, first and foremost, it encourages innovation and sustainability design in engineering education. Next, it improves student real-world project management skill. Besides that, it can be scaled by NGOs or public programs. Other than that, it promotes knowledge sharing on clean water and sustainability. For society, first, it can improve health by reducing waterborne disease. Next, it reduces plastic waste through reusable filter. Next, it empowers low-income communities to build their own water system. Besides that, it is useful during emergency due to its electricity-free design. And last but not least, it is open economic opportunity for local small business. We also consider ethics, ensuring fair access, transparent limitation, and respect for cultural practices around water use. We also consider ethics, ensuring fair access, transparent limitation, and respect for cultural practices around water use.
In the conclusion, our project is economically successful and practical. It not only low cost but also provide high return over time. We also calculate several financial indicators, for example, NPV, which is positive, internal IRR, which is higher than MARR, our payback period, which is in a short period of time. We also calculate our annual feature and also BCR. It shows our financial is strong. In summary, our filtration system is affordable, profitable, and easy to design. It also helps to improve the environment, and I highly recommend it for real-world application, especially in community or emergency setting.